lot many. Okay, print I, leave it. Okay, if I execute it, what I will get? I am getting all the image names. Okay, so whatever the image names are there, that I am getting. So instead of printing I, what I will do, I will print os dot path dot join. Okay, and what I have to join? I have to join two things. First loc1 and second I. Okay, because loc1 will remain constant. Okay, you can see loc1 will remain constant and I is continuously changing. That means each time it will consider a new path, right? So each time it is considering, it is giving you a new path. So if it is accessing each time new path, that means each time in each loop, okay, it will read a new image. So in each loop, it will read a new image like this. I am read. Okay, in each loop, it will read what? It will read a new image, right? And what you can do, we can just store this image over here in f1. f1 is equal to this one. Okay, and then store this image in a features is equal to null array. Store this image in features. Features dot append f1. Better. So your images will get appended in f1. Correct? It is not required over here now. Okay. So if it will be appended, what you can do, you can access the feature. So this is your features. Okay. So we have accessed all the features of motorbike. Okay. We have to check the shape of it. What we can do, we can use import numpy as np. Okay, and np dot array features dot shape. Numpy, sorry, numpy. Okay, numpy. Okay, so it is what 788. Okay, because there were so total 788 images, but it is not what that we required. Actually, what we required, like if you are accessing the features, right? So there are 788 features. That's okay. Okay, that's fine. That is acceptable. But again, these are not a single dimension feature. The features are what? The features are basically the images are in a this is the image. Correct. It is having like 50. Okay, and this is also having 50. Okay, so it is what 50 cross 50, suppose. Okay, so the and it is a colored image, so 50 cross 50 cross 3. Okay, 50 cross 50 cross 3 will be there because R, G and B. Okay, so here the the shape should be what? 788 is fine, that is representing your this thing, number of samples, but along with this there should be something like 50, 50, it can be 50, 70, whatever. That is not, I'm not saying only 50 will be there. That depends upon the size of image. 3. Okay. That should be the complete shape. But I'm getting only 788. Where are the other entities? Okay. There are no other entities. So it shows what? If there are other entities are not present in this case. Okay. If other entities are not present, let's see if it is present for any other case. Okay. So for this one, it is not present. That means what? For motorbike, is it present for airplane? Let's see. For airplane also not coming up. Is it coming for flower? For flower also it is not coming up. Why? The reason behind this one, the other entity that we are not getting, we are only getting the sample size. We are not getting the length and width of it. It is because the images are not in regular shape. Okay, images are not in regular shape. There are certain images that there are the images are in different shapes. Right? There are certain images which are in shape of 100 cross 100. There are certain images which are shape of 90 cross 90. There are certain images which are shape of 120 cross 120. Okay, so images are not regular. Images are different. Images are of different shapes. Okay, and till now whatever things we did, okay, we understood one thing. One thing is very clear, that if you are having 100 sample or 1000 samples or 1 million samples, okay, the number of features needs to be same. If there are 30 features, then all samples should have 30 features. If there are 20 features, all samples should have 20 features. Okay, it is not like that first sample is having 100 feature and second sample is having 50 feature. Then a machine will not get trained properly, or even it will not get trained. Okay, so that means what? In this case also, we have to make sure that all the images should be in same shape, should have a same shape. Okay, if it is 50 cross 50, all images should be of 50 cross 50. If it is 100 cross 100, all images should have 100 cross 100, isn't it? So what we have to do over here, we have to make the change like this: cv2 dot resize. Okay, what you have to resize? You have to resize f1 with a size of what? Like any size we can use. For example, 70 cross 70 I am using. Okay, and then f1r, that is a resized image, and use over here f1r. Okay, and let me use loc1 over here only, right? f1r 70 cross 70, right? And then just figure it out. Okay, some error. Assertion failed. Okay, now done. Okay, then execute. You can see over here, this is what I was expected. Okay, that means 788 images, 70 cross 70 is the image size, and cross 3 because of 3 layer of images, right? Cross 3, right? So that is how it is being defined. Okay, but this is containing the feature of what? This is containing the feature of motorbikes. Okay, I want the feature of airplane as well as I want the feature of flower. Okay, so if I want the feature of airplane and flower, what I exactly do? I will do it for 3 times. Okay, so feature of airplane from location 1, cb2.im read from location 2. Okay, I can give it f2, f2r, that is resized, f2, and add f2. Okay, so f1 location 1 location 1, 2 times location 1, f2 f1 f2 f2. Okay, everything should be correct, right? Here location 3, location 3. Okay, f3, f3r, f3, f3r. Much better, right? So now all the image will be extracted. Okay, and the corresponding features will be stored in features. Okay, execute it. It is executing, doing the process because it is having a star mark. So we can wait for some minute, okay, till the process gets completed.
Sir, can you just like share the file link so that we can also copy and paste the code and try at our end?
Yeah, I can share the file, but it will not get updated in real time. That means I have to save the version and then only I can share. So it will not update in real time.
Okay, sir.
Yeah. So just a minute. I will do one thing for that also. Don't worry. Okay. Fine. So we are having over here features 843 only. Why 843? Because each time I am making the features null. So this should not be there. Okay. Each time what I'm doing, I'm making the features null. That is why the features gets null, right? So, and one more thing I can use over here, that is known as TQDM. I will show you what is TQDM from TQDM, import TQDM. Okay. TQDM I will add over here. So whenever you are running any process, any black box kind of a process which we can't follow, that process is running for long time, okay, then we can use it. And how it will help us, you will see this thing. I will not tell you. It will go give you a progress bar. Okay, this progress bar is showing that when first loop is executing, 788 images extracted. When second loop executed, 727 images extracted. When third loop executed, 843 images extracted. And at the end, your total image size is what? 2358. Correct? So your feature extraction is completed. And then what you can do, you can put this value in X. X means what? Feature. Okay, so it is completed. Okay, so let me share the code with you. What I can use, I can use so paste bin. Oh, okay, so whatever code till now, I will just copy it as it is. Okay, and thereafter then this is a link. Okay, so okay, what do you think? Is plant leaf disease dataset available? Plant leaf disease dataset. Let me check if it is available or not. I have shared the code with you. Just access it. If it is available, then I will use that one also. Plant leaves. Yeah, rice leaf digit dataset. It is there. Plant village dataset. New plant digit dataset. Okay, so it is there over here. Okay, it's a huge dataset. 3 GB of data. Okay, let me check. Train. Yeah, it's there. Okay, so after completing it, I will use this one also. Okay, for the next model, I will use this particular data. Right, let's see. Okay, fine. So our feature is extracted. I hope you got the code also. Right, next thing that we have to do is what? We have to extract the labels. Right, so for extracting the labels, what we need to do, we have to apply the same logic. Let me copy and paste the same thing over here again. Okay, okay, and I can use over here labels. Okay, and this is what I will remove because this is for the features. Okay, and in the labels, what I have to do, I have to append labels dot append. That means for all the files in location 1 that is having airplane images, 0 will be appended. Okay, and all the files from location 2, sorry, location 1 is having what? Location 1 is motorbike. Okay, motorbike, airplane and flower, right? So motorbike, all the images for labels dot append 1, labels dot append 2. Much better. Okay, so you append these things to create the labels. Okay, labels are also appended. Use y is equal to np dot array labels. Right, so as of now, what? Yeah, please.
So why we are using this like 1 2 append 0 cannot be append like from 0 in log 2 and log 3.
Log 3, I'm not getting. Log 3, log 1 means what?
Like in motorbike images, we are appending like from the 0, I mean 0 index, right?
Mhm.
The
Mhm.
images. In log 2 also we need to append the from the 0 index, right? Why we
No, no,
are
no.
writing this 1 in the bracket and then again in log 3 2 in the bracket?
No, it is not like indexing. It is like, for example, if you execute this thing, just a minute. If you execute this thing, print I. So what it will access? Sorry. So if you access it, right, so what are you getting? You are getting these things. Okay, that means each image are there. So for each of the image, what are we doing? We are appending 0. That means we are assigning a label 0 to for all the motorbikes. Okay,
Okay, now got it. Yes, sir.
so it is assignment of label. So for all motorbikes, we assign 0. We added 0 for all this one flower. We append 1, and for all airplane, we appended 2, like that. Or some things are there. Like you can just follow this thing. Okay, so for all the files, all the images in motorbike, if there are 788 images in location 1, then 788 0 are appended. If there are 727 images in location 2, 727 ones are appended. And if there are 843 images in location 3, like 2 is appended for 843 times, right? So we are having x, we are having y. Okay, so once we are having x and y, what we can do, you can just check, confirm the shape of it, x dot shape. Okay, and print. Okay, why it is saying not having shape? Have we not executed this? Tuple object has no attribute shape. Why it is showing like this? Just a minute. Oh God, I have already assigned the shape to it. I'm sorry. Okay, now it's fine. Okay, so x dot shape print x dot shape. Okay, and print y dot shape. Okay, so you can see shape is like this. Okay, the file that I have shared. Just a minute. I guess you have to check it. There I did mistake or not. If I did, you can just correct it, or I will share the new file. Yeah, here also I have written save. That means in the X I am assigning the save. Okay. So please do correct. You have to not to assign the save over here. You have to assign the features only. Okay. Or better, let me share the new code. This is for feature extraction. Okay. Thereafter we are having, this is for X, that is your feature is appended into X. Then we are having, this is for label extraction. Sorry. Okay, and then we are having this thing for assigning label into Y. Okay, so this is a complete code. You can just use it like as it is for feature extraction. It is a process just of feature extract. Oh my God.
Sir, it's okay. You just write like on the main code, like in Kaggle only. This is like the code for the feature, so that like we
Yeah,
can
right,
refer
right,
in
right.
future. Yeah, here only you just write.
Okay, fine, fine. So I thought like you were also coding. That's why.
Yeah,
Okay,
we are, but it's just copy and paste. So like in the last also, you will be sharing the link. We can
okay, fine.
practice. It's okay. Yeah.
Okay, okay, that's okay. Okay, so okay, so we are having feature and X and Y is we are having. Now we have to proceed for our model preparation. Okay, so for model preparation we need some libraries, right? So what libraries we are going to use? We will use the same library or same thing that we used earlier for ANN, right? We will take the help of Keras and TensorFlow. Okay, Keras is a library that we are going to use. Correct. So first of all, we have to import Keras. Okay, import Keras. Okay, then we have to import the type of model. It is a sequential model, right? There are two kinds of model, sequential and functional. So here we are going to use sequential model. So from keras dot models import sequence, right? That's it. Thereafter we have to import some layers. Okay, so what are the layers we are going to use? We are going to use dense layer, activation layer, flattened layer. Okay, so from keras dot layers import, we have to use what? Dense layer. Okay, dense layer for defining the hidden layers and all. Okay, we have to use activation function in value and all to break the linearity. Okay, if you have to break the linearity of your model, we have to use activation function. Okay, then we have to use flatten. Flatten for what? For defining the final layer. You can say the fully connected layer, FCN. Okay, then we have to use con2D for the convolutional layer. Conv, spelling is correct, yeah, con2D. Then we have to use max pooling layer for max pooling the things, max pooling 2D. So these are the inbuilt layers, inbuilt thing that we can just import. Okay. Thereafter, we have to import one more thing that is known as utils. Okay. So what is utils? From class dot utils import np utils. Okay. So what is utils exactly? Utils will be used for one hot encoding. Okay. It will be used for what? It will be used for one hot encoding. Have you used one hot encoding earlier? Just let me know. No? Okay. So what is one hot encoding basically? If you are having three labels, right? So you are having what? Three labels, 0, 1 and 2. So 0 will be represented like this, 1, 0, 0. Okay. 1 will be represented like this, 0, 1, 0. Okay. And 2 will be represented like this, 0, 0, 1. Okay. So it is called one hot encoding. Okay. Why it is required? Because at the output layer, you will have three neurons. Correct. There are three neurons you are having, right? So it is a supervised learning. Suppose all the processes went before it. Okay. And after the processes went before it, you reached at the last layer. When you reached at the last layer, you got over here three, you got over here five, you got over here, suppose two, right? Three, five, two. And your label is this one. Okay, it is your label. Okay, it is your final label, and it is the final value that you got. Thereafter, over here, softmax activation function will be applied. When softmax activation function will be applied, it will be e to the power e minus 3, sorry, e3 upon e3 plus e5 plus e2 to calculate the probable value. Okay, to calculate the probability. The same way over here, e5 upon e3 plus e5 plus e2 exponential, and then exponential 2 upon 3, 5, 2. Okay, so you'll get the probability over here. Suppose over here you got a probability 0.3. Okay, over here you got a probability, suppose 0.5. So over here you'll get the probability what? 0.532. Okay, so what final output you are having? This is your final label. Okay, and it is what? It is your probable value that you got. I'm just taking example. Okay, so the thing is how your model is going to tackle error or figure out the error. Model will use cross entropy to figure out cross entropy to find out the error. Okay, what is cross entropy? It's very simple. 1 minus 0.3. Okay, 0 minus 0.5, 0 minus 0.2. So when you subtract this value, you will get a negative value. So model will ignore these things. Okay, 1 minus 0.3 is equal to 0.7. So this is an error for model. Okay, so model will do what? Model will back propagate. Okay, it will back propagate to diminish or to remove or to decrease this particular error. Okay, model will back propagate to decrease this error. Okay, it will back propagate to decrease this error, and when it will decrease this error, obviously the value of this neuron will increase. Okay, when it will back propagate and when 0.7 will decrease, that means it will increase. Okay, so it will increase to a best possible position. Okay, it will keep back propagate, forward propagation, back propagate, feed forward, back propagate, feed forward. Okay, and finally with the different weights manipulation. The weights value will keep changing, and when weights value will keep changing, at the end what happen, it will reach to an extent, okay, it will just reach an extent where this thing is having a highest value as compared to others one. Like this one is having just 0.5, 0. So this will decrease, okay, this value decrease and this will increase, okay, because ultimately it needs to figure out the weight that can represent the first sample, that can represent the first category. Okay, if it is 100, that means it is what, it is a motorbike. Okay, if it is motorbike, that means this neuron value should be at highest position, this should have the highest weight. Okay, this should have the highest weight, or this should have the highest value. Okay, so this would, when this will have a highest value, when the error will decrease. And what is error? 0.7, because 1 minus 0.3, 0.7. This is called cross entropy, right? So that's why we need one hot encoding to represent your data points, so that cross entropy value, cross entropy error value can be calculated. And who will give us that particular one hot encoded value? This utils. Utils is a library that will give us, right? So what we have to do, we have to now proceed for the next stage. Okay, so what are we having? We are having a value x and y. It is keras dot model size. From keras dot layers, import dense, activation, flatten. Some spelling may be incorrect. Let me check one by one. Yeah, it's worked. Worked. Okay, the last one. Max pulling 2D. That means max P is capital or small. That is what I guess P is capital. Ah, that's fine. Okay, so it is imported, right? Now what we can do, we are having x and y. So what we will do, we will divide the x and y into two parts, right? So from sklearn dot model selection, import train test split, right? And then x train, x test, y train, y test is equal to train test split. Okay, x comma y, correct? It will split the data into two parts, x train, x test, y train, y test, right? So you have divided this thing. Now what we will do, we will try to convert the things into categorical value. So how to convert? Very simple. Y train is equal to, okay, y train is equal to what? Np dot, sorry, np underscore utils dot to categorical. Okay, and you can use over your y train. Okay, and your y test. So if you check now y train and y test, what will you get? You will get this one hot encoded value. Okay, 0 1 0. If it is 0 1 0, that means this is sample. This sample is representing 1. Okay, 0 1 0 1 0 0. This is representing 0. Okay, the same way y test will also have the categorical value. Correct. So when it is done, what we can do, we can go and create our simple CNN model. Okay, so let's create our simple CNN model. Our data set is ready now, correct? So for creating simple CNN model, we will start with model is equal to sequential for defining a sequential model. Okay, and then the first we have to define a convolutional layer. Okay, so model dot add. Okay, and what we have to add? We have to add convolutional layers. So CONV2D. Okay, and then we have to define over here the number of what? Number of filter. So I want to use 32 filter of size 3 cross 3. So this is defined. 32 filters of size 3 cross 3. Okay. If you want to use padding, you have to use padding. If you don't want to use padding, you can leave it. Okay. But if you want to use padding, you have to use padding equal to what? Same. So it will add a padding so that your output and input size should be same. Right. It will just add a padding so that input and output side should be same. And thereafter, what we can add something over here that is known as input save, right? Because input needs to be defined, right? So input save. So what is input shape exactly over here? The input shape is going to be according to the size of data. So xtrain dot shape. What is the shape of xtrain? It is 1768 cross 70 cross 70 cross 3. So it is going to be your input shape. Correct. It will be what? It will be your input set 70 cross 70 cross 3, because 1768 is what? Is the sample size, right? So you can do what? You can use one. Okay. So from location 1, everything I'm considering, right? Index 1. So you just copy and paste it over here. So that if you change the data also, then also input shape will automatically get changed. Okay. Input shape will do what? Or input shape will automatically get changed. How can I? Right. So input shape will automatically get changed. Correct. So this is your first layer. Correct. And after defining the first layer, what we have to do? We have to define over here model dot add activation function. Okay. So activation is what? Activation layer. Activation is to rally. Okay. Rectified linear unit. So we used what? We have used conf 2D and we have used activation. These two things we have used over here. Activation layer for activation, conf 2D for convolutional layer. Okay. After this, what I told you, we can use max pooling. Okay. After this, we can use the max pooling. So model dot add. If you don't want to use after the second layer, also you can use max pooling. But I'm using over here just for I'm creating a basic model. That's why max pooling 2D. Okay. So when you are using max pooling, you have to just define over here the pool size. Okay. So pool size, as I told you, for maximum cases, it is used in a 2 cross 2 size, but there is nothing like that. You can use only 2 cross 2. You can use 3 cross 3, 5 cross 5, 7 cross 7. Whatever max pooling you want to do, you can do. Okay. But for maximum cases, people use 2 cross 2. That's why we are also using 2 cross 2. Okay. And then what we can use? Dropout. I hope you know about dropout. If no, you can ask me. I will let you know. Okay, dropout. Dropout will just drop out some percentage of your weights. Okay, it will just remove some percentage or will drop out certain percentage of your weight just to make sure that your model should not overfit. Okay, just to make sure that your model should not get overfitted. Correct. So this is one convolutional layer. The same way I can copy this whole thing and can define one more convolutional layer. In the second convolutional layer, input shape will not be defined because now input is coming directly from the previous layer, correct? And rest everything is same. Okay. What else we can do? If we want, we can just increase it to 64. Okay, and can increase the dropout also a bit. Correct. I can define one more. So three convolutional layer. Okay. So this is my third convolutional layer. I can make it 128. Max pooling 2 cross 2, I can make it 50%. Correct. So three convolutional layer I used. Okay. And then at the end, I can define the final fully connected layer. So to use fully connected layer, we have to use model dot add. Simple, I have to write over here flatten. So flatten will do what? Flatten will just convert the two-dimensional or three-dimensional matrix, whatever the matrix sizes are there. It can be two-dimensional, it can be three-dimensional, it can be n-dimensional. That n-dimensional matrix sizes, obviously after this there will be an n-dimensional matrix, right? After this there will be a n-dimensional matrix. Okay, like kind of if it is 3 cross 3 cross, or you can say what was that? 128 layer will be there. Okay, so that will be converted into single dimensional array with the help of flatten. Okay, And then at the end, model dot add dense. Okay, this dense layer will have what? Will have the number of classes. So how many classes we are having? 3 classes. Okay, and the activation function. Activation is equal to softmax. Okay, so this is your complete model created. Okay, it is a basic CNN model that is created. Some error is also there. Okay, this is not required actually. I have added equals. This is a function, right? So for a function, equals are not required. Max pooling, activation, conm2d also function, activation is also function, max pooling is also function. Everything is a function. So dropout is also a function, right? So that's why equals is not required. Now what happens? Dropout is not defined. Okay, I guess I have not imported dropout. So you can just import over here dropout. Okay, done. Okay. Now we have to look how the model is looking like. So just use model.summary. So when I use model.summary, what I am getting total learning parameter is 1,17,827. Okay, this is the total learning parameters. If you can see how it propagates like this. At the first layer, it is 70 cross 70, and I used 3 cross 3. Okay, so 3 cross 3 cross 32. Okay, so that means 9 cross 32, right? That means 9 cross 32 is used. Okay, so based upon that, the thing is calculated. Okay, that means the number of learning parameters are calculated. Thereafter, after this, you can see over here, it gets half. Because of max pooling, it becomes 35, 35 plus 35 plus 32. Okay, so 35 cross 35 cross 32 is up to this point. Okay, first 70 cross 70 cross 32, then activation is added, then max pooling, then after max pooling it gets half. Okay, after dropout, this is also 35 cross 35, because in the dropout weights are affected. Okay, number of neurons are not gets affected, number of neurons will keep same, the weights will the 20% weights will not be considered. Okay, thereafter again I added 64 what 64 filters. So as I added 64 filters, this 35 cross 35 cross 64, it becomes 35 cross 35 cross 64. Okay, it remains 35 cross 35 cross 64. Then dropout, sorry, max pooling, after max pooling, it is 17 cross 17 cross 64. Okay, and then again one more layer added with 128. So after 128, it becomes 17 cross 17 cross 128. Okay, it remains 17 cross 17 cross 128, but after dropout, it becomes 8 cross 8 cross 128. Okay, it becomes 8 cross 8 cross 128, and it remains 8 cross 8 cross 128, and then it gets flattened. So if I calculate 128 cross 8, what I will get? I will get 828198. Just multiply it. Okay, you will get this thing. It gets flattened, and this flattened being multiplied with 3 layers. So that's why 8192 multiplied by 3 plus 3, you are getting this thing. Correct? If you want to continue it more, you can continue it more. Okay, for example, if I will use one more kind of a filter layer, suppose I added one more filter layer, so it will become 4 cross 4 cross 256. Okay, it can become 4 cross 4 cross 256. That also I can show you. Let me use it.
Sir, please once again tell me for dropout.
Dropout. Okay, fine, I will tell you dropout. I thought like dropout is been covered in neural ANN. That's why I skipped that. But anyway, I will tell you. So increase it to 256, and again increase it for one more time. 512. Okay. Let's see. So you can see over here, From 8 cross 8 cross 256 is become 4 cross 4 cross 256. Then 512 is added. That means 512 filters are added. So it becomes 4 cross 4 cross 512. Okay. Then again after dropout, it remains 2 cross 2 cross 512 and 2 cross 2 cross 512. This is the final thing. Okay, 2 cross 2 cross 512 and it is 2048. Right. So that's how it. If I will add one more layer, it will throw exception because it reaches to its maximum extent. Okay. So that's why at the end we are having total 15 lakh learning parameters. Okay, let me explain dropout. So what is dropout exactly? Suppose you are having a neural structure like this. Okay, and these are your hidden layers. Okay, so these neurons are connected to these hidden layers using the weights. Right, these are the weights. Okay, so first of all, why dropout is used? Dropout is used to overcome overfit. Okay, to to overcome the situation of what overfit. Okay, so that overfit can be ignored. Okay, now thing is why overfit happens. Overfit happens because of overweights. Overweights. Okay, overweights means what? Overweights means like kind of so many weights are over here. Like there are so many weights. Okay, there's a huge number of weights. Okay, huge, because of huge number of weights, what happened exactly? Your model size increased. Okay, this is your size of your model and this is the size of your problem. Okay, your problem size is small, that means number of samples you are having is less number. You are having a very less number of samples. Suppose you are having just 2000 samples, you are having less number of features. Sorry, category, you are having just 3 category. So 2000 samples is representing this 3 category, and you are having you have generated a huge number of weights because of huge number of this dense layer, or you can say the hidden layer. Because of large number of hidden layer, large number of weights are generated. In that case, what happens? For each particular category, for each particular sample, okay, for each sample, weights will just arrange themselves. Okay, weights will just tune themselves to give you a best possible accuracy. Okay, weights will just tune themselves to give you best possible accuracy. Even it can give you 100% accuracy. Okay, just because you are having so many weights. For suppose, so for first sample, okay, some weights are basically tuned themselves. For second sample, certain some weights tuned themselves. For third sample, some other weights arrange themselves. For fourth sample, some other weights arrange themselves. Okay, so to give you best possible accuracy. Okay, so in that case, what happened? For the learning, for the training data, you will get a high accuracy. But when the same model will be used for the case of unknown data, okay, those weights may not suit the situation. Those weights may not help in that situations. Right? It is a case like whenever a student basically learns everything from a book and he didn't understood the concept, and he is sitting in the exam. In that case, if he get the known question, he will give the all correct answer. But if he gets the unknown question, okay, he will just write anything and he will not get that much good marks. Same thing happened over here. In this case, model didn't learn. In this case, we can say it is a kind of a machine learning in which model memorizes your values. Instead of getting trained, it memorizes the thing. That's why what we do, we just drop out some number of weights after each layer. Okay, like 20% of the weight. That means out of total weights, only 80% of the weight will be considered. Okay, 20% random weight will not be considered, will be just ignored by the model. Okay, the value of only 80% weights will be considered. Just, and then after this thing, only 70% weights will be considered. Okay, so we just limit the, what we do, we just limit the use of weights by the model. Okay, so that model can't use 100% of the weight, because we know if it will use 100% of the weight, then in that case it will give you a overfit model. Then you may think like, why are we dropping out this particular thing? We can decrease the number of neurons. Yeah, that is also a way. Okay, that is also a way in in which what you can do, you can decrease the number of learning parameters by decreasing the number of neurons. That means I have used 5 layers, we can continue with 3 layers only. Okay, we can continue with 3 layers, we can continue with 2 layers. Okay, that also we can use. It depends. Okay, so both things are possible. Okay, if you want to decrease the number of neurons, you can decrease the number of neurons. If you want to decrease the number of weights, you can use dropout. If you want to use both of them, you can use both of them. Am I clear?
Yes, sir.
Okay. So your model is finally created. Now what we can do, we can train our model. So how can we train our model? For training our model, the very first thing we have to do is we have to define the optimizer and all, right? So we have not imported any optimizer, right? Have you imported? I guess we have not imported. Have we imported the optimizers? No, we have not imported. Optimizers means what? The same gradient descent and all, right? So we have to import the gradient descent and other optimizer for our need, or we can also from Keras import optimizers. Yeah, fine, it's okay. Okay, so what we have to do, we have to define the optimizer over here like SGD. SGD can be your optimizer is equal to optimizers, that is stochastic gradient descent, optimizers dot SGD. Okay, or it is, I guess, capital SGD. I'm not sure. If it will throw error, I will make it correct. Okay. Okay, so first thing we will define over here the learning rate. Okay, I hope you know learning rate. If not, then you can just let me know. Okay, so this is what, this is your learning rate, right? That I have defined some random learning rate, right? Because I am not known, I'm having no idea how model will behave, so I have to define something, so I just define it, and thereafter what I have to do, I have to compile the model. So compile. Okay, compilation required certain thing like loss. What will be the loss of it? So loss will be categorical cross entropy, as I told you. Categorical cross entropy. Okay, and optimizer will be SGD that we have defined just above it, and matrix accuracy. Okay, done. Okay, and then model dot fit.
Sir, can you just explain like some, can you just like highlight some more information about optimizer, this SGD? Though Umang sir, he has like covered the learning rate, but this part I think he hasn't covered
SGD.
SGD.
It
Yeah.
is a gradient descent optimizer that I guess I had covered.
Okay,
Like,
okay, okay. This is like the object for it. Okay.
yeah, right. This is the
So what
inbuilt
is the
library.
S? This is
Stochastic.
S
The full name over here is, just a minute.
SGD, gradient descent.
Stochastic gradient descent. Stochastic means what? Stochastic means it's like, there is a way. Suppose if you're applying a gradient descent, then how can you apply? There is a way you can apply that. You can apply a gradient descent like this. Like when we coded earlier in linear regression, you may have seen that what we used, we had calculated the complete error. If you are having 100 samples, right? Then what we did, you can calculate the complete error over here. Okay, and then you are tuning this error, isn't it? If we had seen in gradient descent, right? That means complete error, we calculated the sum of the error and then we were tuning it. Okay, in stochastic what happened, it is one by one. Okay, same process will be done, but it will be done for one by one, each sample. Okay, for each sample it will be done, or it can be done for a group of sample. That means if you are having 100 sample, what you can do, you can use a batch size of 2020. So gradient descent will be applied on first 20, error will be optimized, then next 20, then next 20, then next 20, like this. That's why it is named as stochastic gradient descent.
Okay, sir. Okay.
Right. So we can use it. It is the same formula that we use, but since it can be used layer wise, that's why, that means it's group wise, that's why it is named as stochastic gradient descent. Thereafter model dot fit. Okay, what we can fit over here, we can fit the data like x train comma y train. Okay, and we can give a batch size, as I told you, batch underscore size is equal to, suppose I'm giving a batch size of 120 or 128, any batch size you can give. That means In one cycle, 128 sample will be considered for getting trained. Okay. Then we have to use what? Epochs. Epochs equal to 30. Okay. And then I can use validation data as well. Validation underscore data for validating the things. So validation data equal to what? It can be X test, Y test. That's it. Okay. So if I execute it, I hope I should not get any error. Okay, no error. Okay. So it is what I'm getting. Accuracy is 35%, validation accuracy 29%, accuracy 34%, validation accuracy 29%. 34, 29, 24, 29. That means it got stuck somewhere. We'll improve it. Let it be completed. Okay. So at the end, we got 34 and 29. Why are we getting it? Okay. Why are we getting this particular accuracy? Can anyone let me know how can we improve it? What thing that we didn't used over here? That's why accuracy is less. We had not used one very important thing that is known as normalization. Okay. For example, when we are using X train and Y train over here, you can see X train and Y train, this is your data value, right? So if you call X train, okay, the values are quite big. Okay, the values are what? The values are quite big over here. As it is quite big, right? The optimizer is unable to optimize this thing on a proper interval of time, or the weights are not getting optimized properly. Okay, so what we can do, we can just normalize it. Okay, what normalization means? Suppose you are having a value, and normalization means converting the things into between 0 and 1. For suppose you are having a value 5, 7, 3, 2, 1. Okay, and then I have to normalize it, and I want the differences should be same so that I should not lose any information. What I can do, I can divide this thing by the maximum. Okay, so all value will convert it in between 0 to 1. Will it give any effect on my data? Let's see it is giving any effect on or not. I will normalize, and I will store this thing. Xtrain n is equal to what? Xtrain divided by Xtrain dot maximum. Okay, then same X test underscore n is equal to X test divided by X test dot maximum. That means Xtrain n and Xtrain x are the normalized value. So is it there is any effect because of it? Let's see. Import matplotlib dot pyplot as plt dot imso for showing the image. Consider any single value Xtrain 56 and plt dot so. So this is your original data, right? So this is your original data showing a particular image. Okay, I have to check, is there any effect because of normalization? Because of normalization, the values becomes converted in the range of, you can see over here, Xtrain underscore n. It is converted in the range of 0 to 1. Okay, so we can think that there can be a loss of data or something like that, right? So what we will do, we will just copy this part and we'll paste over here, and I will change Xtrain into Xtrain n. Okay, so there is no such loss because ultimately the ratio between the values remains same. Okay, but the mathematical term, the mathematical value decreased a lot. Okay, so will it help? It will help a lot. I will show you. Let me change the location also. 561. It is airplane 561. It is also oh, sorry. You can see no change, almost same. Okay, so if it is almost same, so will it help you? Okay, let's see it is helping us or not. Xtrain, Ytrain is already there. That's good. Model is defined. Model dot summary is remains same. Okay, optimizer will remain same. Xtrain underscore n, Ytrain underscore no, Ytrain will remain same, right? Xtest underscore n. That is a normalized value. Okay. So accuracy improved. It becomes 62, 63, 65, 65, 68, 69, 70, 73, 75. So it touches around 75% as of now. Okay, validation accuracy is also improving. So you can say my model is not getting overfitted actually. Okay, it is going good. Okay, because validation accuracy is also increasing. It touches around 75%, right? For after 30 accuracy. But you can see over here there is a change happening, right? From 73 it moves to 75. That means there is a much more chance of improvement. Okay, there is a chance of improvement. So what I will do, I will execute it for 30 more times. Okay, I will execute it for 30 more times. 79, 77, 81, 85, 82, 83, 87, 88, 89, 90. Okay, so it touches around 90%. Okay, the validation accuracy is 89% and the training accuracy is 91%. Okay, that means it's still a chance of improvement we can assume, right? So for just for confirmation, we'll execute it for 30 more times. That means total 60 times I executed and 30 more epoch. Okay. So it around 94, 93%. Okay. So obviously it is working good, but it took around to get 90%. It gets a kind of it uses around 90 epochs, right? So can we increase the speed of learning? Yeah, we can use what learning rate. Okay, that means we can take the help of learning rate. We can increase the learning rate a bit. Okay, it may possible learning rate is slow. So what I will do again, I will define the model. And this time what I will do, I will define a little bigger learning rate. Okay. And instead of 30 epoch, let me give 40 epoch over here. And I am assuming of 45 epoch, right? Half of the total that I did earlier. Okay. Good. So you can see what I expected, it is going in almost in same. So almost in half of the epoch, okay, it touches 90%. Okay, 93, 90% accuracy it touches. Okay, if just for satisfaction, if I will execute it for 45, so you can see over here, it is at 90%, 93%. Maximum it is having 90. If I have to calculate the maximum things, what I can do, print model
So
dot
where is the training accuracy?
uh,
Where we can check?
just a minute. You can check the training accuracy is over here. This is your training accuracy and this is your validation accuracy after each epoch, right? Or you can do like this also, model dot evaluate x train underscore n comma y train. Okay, this will give you the training accuracy, and then in the next line, model dot evaluate x test comma y test, right? Okay, so training accuracy 93%, final maximum training accuracy 93%, and maximum testing accuracy. This is what you can use like this also. Just give one location one. Okay, so this is your training accuracy and this is your testing accuracy, right? Yeah, right. Okay. So why it is showing 56? Because according to batch size, it is showing 56. Okay. Because if you see total size x train dot save, what are you getting? 1768, isn't it? So just take the first value 1768. Correct. Divided by total batch size, that is 128. 128 I had used or what I had used? Oh, okay. Over here it is showing 14, right? 14 means what? Because 13 point something it is showing. 13.8185, 8125. That's why total 14 batches are there. But why it is showing 56? There can be something over here. Okay, I will see this thing, or the figure, like why it is showing 56. Before that, let me tell you one more thing. Like, if what happened if I will run it for more times, that means it is done for how many times? For 45 times. Okay, 45 epochs, right? If I will execute it for 45 more times, then what exactly will happen? If accuracy is increasing for both training and testing, it's good. But if it is only increasing for training, not for testing, okay, then we can say model gets overfitted. So at the end, what we are having this thing, 99% for training and 98% for testing. That means this model we can't say is overfit, because whatever the accuracy that it is showing on the training data, for unknown data it is showing almost that much close accuracy. So my CNN model is successful for it, and it is giving us the better accuracy for my model. Okay, now you have to make the prediction. So how can we make the prediction? We can make the prediction over any single value. We have to use, suppose, X test 98. This is a sample I am picking up. I have to make the prediction. So what I will do, model dot predict. Okay, so it is throwing a exception because of shape problem. Why it is having a shape problem? Because when, if you check xtrain dot shape, what is the shape of it? It is 1768 cross 70 cross 70 cross 3, 4 dimension, but it is having a shape of what? Three dimension. So shape mismatch is there. Okay, but it is a single sample. First one is your complete sample, so you can reshape it. Single sample will represent 1 cross 70 cross 70 cross 3. Better. And this is what you are getting, 001. 001 represents what? 001 represents your third category. Third category was what? Third category was, if you can see, a motor airplane flower. Motor airplane flower, right? So what we can do, we can use over here np dot arg max. Okay, numpy arg max, that is argument of maximum value. What error I am getting? Just a minute. It is an error, right? Import numpy as np dot arg max. I got over here too, right? So why I'm not getting this thing? Okay, just a minute. It's fine. I should get. Yeah, fine. I'm getting 2. Okay. So 2 is representing what? 2 is representing our flower. So I will do one more thing. Predicted label is equal to, okay, first one is your motorbike. Second one is your what? What was the second one? It was airplane, right? So airplane. Third one is what? Motorbike. Sorry, flower. Okay. And this predicted label I will pass through it. That means this arg max will be passed through this predicted label. Okay, and it is giving us what? It is giving us 0, 1 or 2. So based upon 0, 1 and 2, you will get the predicted value, that is flower. Okay, image I want to draw, I can draw the image also. Plt dot I am so. Okay, what I have to pass? I have to pass only x test 98. Okay, and plt dot so. Okay, so it is the image that I am getting. and the predicted value also I can print over here. Okay, it is what I'm getting. If I will change the position, let it make it 8. Okay, they all are flower. Oh my god, all the flowers are there or what? 105. No, fine. It's motorbike. 175. Airplane. So it is predicting well. Okay. So now if I have to make the predictions over kind of some unknown data, then what I can do? I have to upload a data. Let me check if I can upload or not. I have to upload a image data, right? So okay, I will do one more thing. Suppose I have to make a predictions, right? So I need an image, right? So what I will do, I will just use a airplane images over here. There's so many images. I want to use the image. Suppose this one I'm using. Okay, view image. Okay, let me check if it is accessing it or not. I'm not sure it will access or not. CV2 dot im read. No, it is not accessing actually. I have to upload it somewhere over here. Hmm. If I can upload a data, I can use it. Okay. Hmm. My image. Okay, it's present over here, right? So what I will do, I will just copy the location and os.list. First of all, I'll confirm the data is present or not. Okay, it is not accessing over here. Okay, fine, it's present, right? So what I will do, I will just use cv2 dot im read. Okay, so it read the data. Okay, and this is the data to be predicted. I will store this thing in p is equal to this one, and then I have to resize it according to the data that I'm using. So p is equal to what? cv2 dot resize. Okay, I have to resize p in the size of 70 cross 70, right? 70 cross 70. Okay, so it will be resized and thereafter it can be predicted. Okay, so what I have to do, model dot predict. Okay, model dot predict, and I will pass, or I will copy this whole thing. Okay, and I will paste it over here. Okay, model predict label np.ai model dot predict, and here it is x175, where I will pass just p reshape, and all those things will be there. Okay, and as well as I will copy this whole thing for image. Yes, it will be just p. Better. So it is predicting over here as a motorbike, I guess, right? Yeah, it is.
But sir, accuracy is very high. Then also it is predicting wrong.
Yeah, right. It is let me check the things. So P dot receive 170 cross 70 cross 3. Okay. I'm using the P only, right? P. So okay. So what I will do now, I will just divide this thing. P is equal to P dot max. That okay. Now it is predicting correct, right? So you understood why it was predicting wrong? Earlier, why it was predicting wrong? You understood? It was predicting wrong because I was using the data as it is, but for training, I had used normalized data, isn't it? I had used the normalized data, but without normalizing, I was using the data. That's why it was predicting wrong. That's why whenever we have to predict, we have to use normalized data. Like here also, I am not using normalized data for predicting. It is just a luck that it is predicting correct over here, right? It is just a luck that it is predicting correct. Here also, it should be a normalized data should be used for prediction. Okay, that means it should be divided by what? It should be divided by, or you can say not divided by, it should be used over here x test underscore n, right? Here also we should use x test underscore n. Oh, but image zone can be used anything. Okay, this is what we should continue. Okay, we should not use the data as it is. If we had used normalized data for the training, now if you use normalized data for the training, now for the prediction, you can see what you are getting. You are getting the probable value of each neuron at the output layer. There are three neurons at the output layer. This is the probable value of first one, second one, and third one. Am I clear? Okay, so these are the small things that we should take care of, okay, whenever we are creating any model, right? Now okay, so this is how your CNN model works. Okay, now if you have to make a VG16 model, right, in this case only there are a little bit changes you have to add. Like in VGG16 model, there are two layers over here before max pooling. For example, if you have to create a VG16 model, you can please mute yourself, everyone.
Sir, can you please share this code of file first? I mean,
Okay, I will say. Please, if you are not required to ask him to please mute yourself. If he is not muted, actually it will create a problem. Okay, whenever you can, you can just unmute and you can speak out, and then you can. Otherwise, it will create a noise and. Okay, so let me share this thing. Natural message CNN. Okay, I have to first save the version. So version quick save. Okay, then copy, make it public. Okay, so you can access it. The code I have shared with you. Correct. The on the other side, if you want to use it, then how you can use it? First of all, you have to understand it, what it is, what the data we are having. We are having a data of different leaves. Okay, and it is a
So can I get the link of this data set, the disease data set?
yeah, you can just get it. Let's see the link. 3 GB disease and pest in coffee leaves. So this one is having XML file as well and JPG file as well. Separate over here XML and JPG. This is a huge data actually, right? So you have to process a lot of things and it will take a lot of time to develop a model for it. Okay, so train. Okay, so apple, these are different kinds of, I guess, diseases. Okay, black apple, black rot. Okay, and
Iris is not applicable. It's very simple Iris dataset.
which one? Iris. Okay, so these are different kinds of images, and with the images the disease name is given in the folder. These are the disease name, I guess. Apple black rot, uh, apple kidder, apple rust. Okay, apple healthy, blueberry healthy, right? So these are the folders. So you have to use how many category over here. There are so many categories. Like as of now we had used only 3 categories, right? So over here there are so many categories. Okay, so same model you can apply over here. Okay, with a little change that I'm just telling you. If you have to convert this thing into what kind of a VG16, you have to do nothing. You have to just add a little bit change over here. Okay, what are the change? For example, in the first layer I have added only 32 over here. Before max pulling you have to add one more 32. That means you have to just copy this thing. Okay, and you have
Sir,
to
request you to please don't make any changes like in the the basic understanding of code, because we
uh,
will be referring first to this. Uh,
So no,
Otherwise,
there
we'll
it
get
no,
confused.
the link that I have said, in that link nothing will change. I'm changing over here.
Okay, okay, sir.
That will remain as it is. I'm just making you understand, like we have to improvise and how we can improvise for better. Like if you are getting a complicated set of data or complicated set of things, okay, so what we can do in that case? We can
Okay,
here
sure,
add
sir. Yeah.
we can add
Thank you.
multiple layers over here before max pulling, right? Because we can't add layers after this, because once you reach at the last point, then you keep adding the layer, it will throw exception because there are no more data remaining for max pulling. Okay, after this what happened? After this only one layer can be given to it. Okay, so once it reaches 1024, after this if you add, it will become 1024. Then you can't add max pulling or anything, isn't it? Thereafter it will be constant. So that's how at a after certain end you can't add the layers. Okay, so but you can add the layer in between. Okay, if your problem is more complex, it is having a more complex data sets and all, you can add a layer in between. Okay, so that is how you can add, like the concept that we had understood earlier. Okay, we can use this thing over here. Okay, as well as you can use one more layer over here. So this is how you can convert this normal CNN into what? Into your VG16, right? That's it. But again, if I will apply this particular model in our case, okay, so it will work, but it may work with very less number of epochs, right? With very less number of epochs. So there are a lot many data set that you can try on, right? You can use this one. Okay, the basic concept will remain same, the programming will remain same, only you have to change the things over here. That 3 location I have used, you can use 10 locations, 20 locations, 30 locations, right? And for all those locations features will be extracted, and for all those locations labels will be extracted. X will be, Y will contain the labels, X will contain all the features, right? And then normalization is very important, and this one is also important, that is known as your one hot encoding. Okay, so you should do these two things, do keep in your mind: one, normalization, and second, one hot encoding that we can use for any kind of purpose, right? So okay, better. And apart from this, this is what on which you can work upon. Okay, and then also there is one more things that you can work upon. There is one more data set that I will ask you to work upon, that is known as sign language data. Okay, Okay, sign language MNIST, right? This is a data set that is sign language MNIST. Okay, it is for identifying the sign language A, B, C, D, E, F, G, H, right? So this also you can work upon. So this is not having any image. This is having just CSV file. Okay, you can see the data is already extracted and you are having a CSV file. Okay, you are having what? You are having this CSV file. Okay, this CSV file is giving you 785 pixels. 785 means what? 785 columns are there. 785 means what? The first column is label. Okay, and after the first column, every other column is what? Features. Okay, total 784 features. 784 features means what? It is just like MNIST handwritten digit data. Okay, 28 cross 28. Okay, first column is showing label. Label is showing 3216. That means the label must be from 0 to 25 or 1 to 26 because there are 26 sign languages. Okay, sign letters, right? So here also you can apply CNN or ANN to develop a model and for making the predictions. Okay, if you want to take the help, you can take the help from this notebook section. There are 254 notebooks. That means there are 254 people who had created the code. Okay, so from the different codes you can take the help as well. Okay, from different you can create your own code or you can take the help from these codes also. Okay, there are certain codes which are not completed yet. Okay, but there are certain codes which are completed also. For example, you can just consider this one. Okay, so for many data set you will get the code there only, or you can create your own code also. Okay, if you're having a understanding, you can create a, this is a code, for example. So whatever code that you get, it is like just now I have created a code. So if anyone search for natural images CNN, he will get my code also, the code that I did over here. Okay, so it is not necessary that all the people will do the code in same way. Okay, different people use different logics, right? So over here, it is a code done by some person, right? So you can go through it, like how did she did the code. Okay, info, head, info, plotting and all. Okay, she did all data analysis and also, okay, testing image, training image, shape and size. Okay, plotted the image also. Thereafter data augmentation. Okay, and then model is defined like we defined it. Okay, here also she uses CNN. It's a simple CNN is used. Okay, and the accuracy she is getting is around 91%. Okay, validation accuracy 91% and training accuracy 80%. So that you can say that it is a quite good model, but you can try with your concept also, that how good it is predicted. This is your training accuracy and this is your validation accuracy. Okay, training and validation accuracy graph is there. And then this is a different analytical things. This is a confusion matrix as well. Okay, so you can try with your logic. I hope you can get a much better accuracy than that. Okay, you can get a better accuracy, and the difference between this accuracy can also be decreased. Okay, it's having the model is good, but there is a huge difference between training and validation accuracy.
Yeah, it seems underfitting one, right?
Right, right,
Underfitting
right,
model.
right. So you can try with your own model and can then check if it can be decreased or not. I hope it can be easily decreased. Okay, if you try with good model, it will be decreased. Okay, so this is it for this part. Okay, in the second part, I will let you know how can we create a model, save a model, and can deploy a model. That means how can we use a model for our real-time use or purpose. So, like for example, when you create a model, right, like this, we can save this model also. Okay, so for saving this model, how can we save it? It's very easy. I will show you. It's like Kaggle save. You can, whenever you want anything, you can just search like this. Okay, you will get the things over here. Okay, in the Kaggle official document. Oh, sorry, not Kaggle similar. Sorry, it's Keras. Okay, so in Keras official document, you will get things. Okay, it is just model.save. Okay, so when you do model.save, your model will get saved. Okay, it is showing over here. This is a complete document. Okay, this is the only file, right? So I'll just copy this and I will paste it over here and then I will explain it. From keras.model load model, it is not required for now. Okay, it is required in the case when you are accessing the model in other program. Okay, this is delete model. It is also not required as of now. Model.load model. So this model.load model and this thing, okay, these two lines will be required when you are accessing this model for other program. Okay, that means if I will execute it, okay, my model will be saved. It will be saved in output working directory. Most probably it will save, it will take a little time to reflect over here, but it will be saved in output working directory. Then I can download that model and I can give you my model.h5. If I'll give you my model.h5, in that case you are not required to do this much code. Okay, you are not required to do any coding. Okay, you can directly use load model. Okay, you can directly use one line, this line, from keras.models import load model, and the second line. Okay, and you will load the model, and once the model is loaded, you can directly make the predictions. Just 3 or 5 lines of code, it will be done. No more training. So this is how you can save the model and can let the model work, right? And the same model will also be used for model deployment. So that thing I will let you know in the next session. Okay, so
Like how client can use it.
right. Client or a developer, like front-end developer, right? Like
Yeah,
suppose there is a
yeah.
front-end developer, they needs to
Because they are
use.
not going to understand this. They need
Right.
something like, yeah.
Right.
Sir, I have a question. Like in my company, we are working on the cloud technologies. For an example, in predicting I'm working with the aviation industry in predicting, the load factor, because we do the marketing for those route where the load factor is less than 75%, right? So we are using cloud technology, AWS precisely, Amazon Web Service. So they are they do this hyperparameter twinning, not manually. There is a grid search CV function. So, sir, in like manual process also, though manual process is like very important now after like your explanation, I got this point because we are working directly on the cloud instead of like this using this. So we are not like aware of, you can say, like the basics from the root as you are aware of. Uh, sir, I mean to say, sir, is in manual process also is something where this hyperparameter twinning, deciding like how many epochs we have to, take into account. Is there is any like automated process we can adopt in this? Apart from this for loop in this manual process?
Actually, the things like when the problem statement changes, right? When the situation changes, everything changes, right? So that's why for each problem we have to take a different approach. Okay, it is not like that single approach you can apply everywhere. Okay, and the analytical process, basically, you are asking me about the analysis, more about analysis, isn't it? Like how can we
Sir,
analyze a problem?
no, sir. Basically, like for creating the model, like the accurate model. For an example, here we are getting the accuracy somewhere like more than 90%, but we are doing everything manually. Like we are changing the epochs, we are adding the number of convolution layers. But like in my company, we are working on AWS. We just like do all this hyperparameter training. I'm just talking about this. The clustering process and uh, regression process, like by using this grid search CV function. Hyperparameter, we need not to do anything like from the basic. uh, so it automatically, give this number, how many epochs we have to use, how many layers we have to take. For an example, deep learning like is something new to me. I'm into like NLP, natural language processing, and this machine learning. So there we use hyperparameter twinning, and that is like automated process. I never gone through this the manual process. So though it's like, thank you so much for explaining like from from the scratch. But like in this also, is there is any automated process, some function uh, where we can know like this is the best accuracy we can get from this number of using this number of epochs, or using this number of layers?
No, like I have not used that thing over here because actually, as I told, like when the problems like this is for this problem, right? Again, when the problem change, everything will change, right? So in that case, there are some libraries might be there that can, in which we can just put the data and can let it into work, okay? And library will process everything and will complete the thing like Microsoft. That one thing is there. Microsoft Machine Learning Studio is there. Are you using SageMaker? I guess AWS is
Yes,
having.
yes, yes, sir. Yes, sir. Yes, sir.
Right. So SageMaker, like you are using, so in the SageMaker also there are lot many libraries. They are having their own libraries are there. So
I
that
think like for this you need to have like more experience. Like for the manual process, like only
right,
experienced candidate can make a good accurate model for the
right, right,
unseen
right.
problems. But like we are like with the cloud technologies where half of the work is automated, so we don't have that much experience which you have like in creating this basic model. That's why I have asked like in this
Right, right.
local. Yeah.
I got got your things like yeah, the process that you are using, that those things are also having a quite good libraries and all that do the task, but still they are still in a developing mode. Okay, so in all the cases you will not get highly accurate thing. So there also at some point of time we need to apply manual, but in coming years those libraries and those things will update it themselves, or people will update those things, so they will also work at a very high accuracy. Okay, for example, I will show you one thing. Like when we go time series forecasting, right? We use ARIMA model. Okay, and ARIMA model is itself a auto-regressive and integrated moving average. Okay, this is used for time series forecasting, right? Like you have to forecast the stock price, or you have to forecast like nowadays this is getting used to forecast the number of corona cases and all, when it is going to peak and when it is going to come down, right? So but now again, if ARIMA model will be used, then it will be everything from scratch, everything will be manual. But nowadays there is a library release, or you can say there is a process released by Abby Prophet, okay, Facebook. Okay, if you use Abby Prophet and you want to do the same thing, right, you have to just put the data within Abby Prophet. Okay, and it will do whatever you want to do, like all the predictions and all those things will be done by just fitting the data over here. Okay, just m is equal to profit m dot fit df, that's it, just two lines of code, right? So again it also works. I had used Arima and I had used this profit also, but the difference is with the profit there are certain limitations. Okay, in some cases it works very nice, it gives a very good prediction, and again in some cases it fails. So where it fails or it was not giving, I can't do anything because it's an inbuilt library by Facebook, right? But if I will create my own ARIMA model, I can do the things, I can tune the parameters, I can give the things different parameters according to my own requirement, right? So that's how it works. So like whenever you are working on that automated process, nowadays automated process is getting slowly successful, but it needs a little time to give you that level of accuracy that you can achieve manually, or you, by tuning the process by on your own hand,
Yes,
right?
sir, I agree. I completely agree. I second your thoughts because there we are getting the accuracy of like somewhere around 70 to 75% max, like for the for predicting the load factor. But maybe like now I can manually go for
Right.
after this session, and I think we can achieve more. Yeah, thank you.
Right. Okay. So, can we take a small break before next session to continue?
Yeah, Bipul, you can take the break, no problem.
Okay, sir. Okay. So, next session is very important. So, I hope you'll join in next 15 minutes, right?
Yeah.
Okay.
No problem. 12:40 most probably.
Okay, sir. Okay. No worries.
Yeah.